Hello friends, hope you all are doing well. This is your friend Rahul and today I will teach you about Gauss Elimination Method. So let us begin. Gauss Elimination Method is an algorithm for solving system of linear equations. It can also be used for finding rank of a matrix, and also if you have given an invertible matrix, it can also be used for finding the inverse of that matrix. And if you see any echelon form of a system of linear equation, then you should understand that the Gauss elimination method or the Gauss elimination algorithm has been operated on that system of linear equations. So how does the Gauss elimination method works? So there is a process to it, and it involves a systematic elimination of variables from a set of equations. There is a pivot equation. This is a pivot equation, and we have one pivot element, that is 2. Let's say in this equation we have a pivot of 2. So what we do is we identify the pivot equation and the pivot, and then we multiply this equation and then subtract in such a way that we try to get one triangular matrix, or we try to reduce that matrix in a triangular form. You should note here that the matrix which is operated in this system of linear equations is the augmented matrix. Augmented matrix is nothing but you take the coefficients of all the variables and you augment it with this set of numbers which is there on the right hand side of the expression on the equation. So once we have this triangular form of the matrix, then we can do a back substitution to find the variables. So let us see this with an example. So consider this system of linear equation. In this we have three equations. 2x plus y minus z is equal to 8, minus 3x minus y plus 2z is equal to minus 11, minus 2x plus y plus 2z is equal to minus 3. So I said we have to do the operations on the augmented matrix. So I have the coefficient of the matrix 2, 1, minus 1 in this, so it has been written here minus 3 minus 1 plus 2, so minus 3 minus 1 plus 2. Similarly for the third equation, so we augment this matrix with the numbers which is there on the right hand side of the expression, so that is 8 minus 11 minus 3. Now in this equation, in the first equation, we select this as the pivot equation, and then we have the number 2 over here as the pivot. So what we do, we try to eliminate the coefficients which are of x which is there in the next two equation, that is equation 2 and equation 3. So we do this kind of row operations. So what we have done is that we have multiplied the first equation L1, let's say this is L1. So we have multiplied this L1 with 3 by 2 so that the coefficient of the new matrix after multiplication becomes 3. And then what we do, we add it, because here we have minus, so we add it, and then automatically what happens is 3 minus 3, it will be 0. So that's why we have not written over here. So in that way we have eliminated the coefficient of x which is there in the equation 2 and equation 3 by this row operations. Similarly, what we do next is we should keep in mind that whatever the operation we do, we have to do that operation in the augmented matrix also, that is the coefficients. Previously we see over here it's minus 11 minus 3. Now because of the operation, this operation, it has reduced to 1 and 5. So that has to be kept in mind, that we have to operate come in a complete row and not on the first few elements. So similarly we do now we consider the second equation as our pivot equation, and we eliminate the variable of y in the third equation. So what we have done, we have multiplied this with 4 minus 4, because we have 2 over here, and then we are adding it. So the resultant of all these things will give you the augmented matrix, the reduced augmented matrix in this form. So this is what we see over here is the echelon form. Now what we see over here is this is a set of linear equation, a new set of linear equations, and here we have these equations. So we have minus z is equal to 1. Now we have z is equal to minus 1. So now we can do a back substitution. So from here what we do, we put z is equal to minus 1 over here, and then we find that y is equal to 3 will come. Similarly, now we have the values of y and z. Now we can put this in the first equation, and then we can get the value of x. So similarly we can get the value of x as 2. So this is what the Gaussian elimination method is. We take the set of system of linear equation, we find out the pivot equation, we find the pivot of that equation, and then we operate it in such a way that the augmented matrix reduces in a triangular form with row operation. The similar thing can also be done in a column echelon form also. The matrix, the augmented matrix can be reduced in the column echelon form, but that is a similar thing, and that is also very easy, and it is the operation has to be done in a column manner, because what we see over here is L2 is a row. In that case, L2 or L1 whatever we have will be a column. So it is a similar process, and it is not very tough, and the Gaussian elimination is very useful in finding the rank of the matrix, and also finding the inverse of the matrix. So if you like the video, do hit the like button, and please comment about the video or any other topic you wish to learn. Thank you.